This video lecture addresses the profession and practice of ecological restoration. When we begin discussing restoration projects, a primary factor in project success, cooperation, and roadblocks is the stakeholders. Essentially, all individuals and organizations with a direct stake in the project, whether it be personal, cultural, or economic, is considered a stakeholder. In many cases, the stakeholders will be local, but there may also be absentee stakeholders, like those that own property but live elsewhere, or those that provide donations to support distant conservation initiatives. Klool and Aronson, 2013, offer three divisions of stakeholders, including local interests, economic interests, and government agencies. There are entire books devoted to stakeholder engagement and resolving conflict in environmental management. Further study in these topics, especially when undertaking a controversial restoration project, is highly recommended. While a relatively young field, ecological restoration is complex and conflicted and deeply tied into ethics. For example, Klool and Aronson note that each individual may have a conflicted personal relationship with nature regarding legacy, utility, and recovery models of ecological restoration. Bringing these models of ecological restoration together for each individual stakeholder may require patience, understanding, and negotiations. A legacy model of ecological restoration relates to what we leave behind and incorporates the ideas of a return of ecological systems to pre-impairment conditions. In reality, this legacy model is not entirely practical, as ecological restoration cannot restore to the past given the current changing conditions. Still, this legacy model remains popular among the public at large, though less so with ecologists with theoretical training. A utility model of ecological restoration relates to the usefulness of certain goods and services, so that the restoration work focuses specifically on targeted functions. Klool and Aronson suggest that afforestation projects, those that improve rangelands for domestic livestock use, projects that improve recreational opportunities, or those that protect water quality are good examples of environmental utility model projects. An ecological recovery model suggests putting a system back on track, in the words of Klool and Aronson. This vision for ecological restoration is more in line with the guidance of the Society for Ecological Restoration International in the SCR Primer on Ecological Restoration. The ecological recovery model selects a pre-impairment target, but recognizes that conditions have changed since that time frame, and so the target is on recovery given the current reality and as part of a historic continuity. A reference model is incorporated in concepts such as ecological complexity, self-organization, resilience, dynamic self-sustainability, and biosphere support are considered. Klool and Aronson note that, quote, the recovery model embraces the realistic goals of the legacy model, provides all of the benefits of the utility model, and returns an ecosystem to wholeness, end quote. Hobbs and others, 2006, describe novel ecosystems or emerging ecosystems as those resulting from species combinations in presence or relative abundances that have not occurred in the past within a given biome. They further offer that such species combinations may result in changes in ecosystem functioning. This concept is attributed to the ideas of H.T. Odum, who noted that synthetic ecosystems include conditions and combinations of organisms never before in existence. The Earth is a dynamic planet, and certainly throughout time novel ecosystems have come and gone. But the term, as applied today, refers to noticeably stark changes in ecological systems as evident in a time span relevant to a human lifetime. Such novel or emerging ecosystems infer a new ecological trajectory that differs from the past and is shaped by the pressures of the present. Ellis and Ramankutty presented a new idea on how humans have influenced the terrestrial systems across the planet in their anthropogenic biomes or anthromes. In brief, they note that, quote, anthropogenic biomes offer a new view of the terrestrial biosphere in its contemporary human-altered form. Most of the terrestrial biosphere has been altered by human residence and agriculture. Less than a quarter of the Earth's ice-free land is wild. Only 20% of this is forest, and over 36% is barren. More than 80% of all people live in densely populated urban and village biomes. And agricultural villages are the most extensive of all densely populated biomes, and 1 in 4 people lives in them. End quote. The authors further break down the concept of anthromes in relation to human population density, land use, land cover patterns, and additional data. Global concepts on human influence on the natural systems and global climate change should be incorporated into even small-scale local ecological restoration projects, since the future is now. The following references were consulted in developing this video lecture.